Welcome. This channel is a raw public journal dedicated to software development mastery. Over the next few months, you'll see me focused on rigorous practice, tackling DSA problems, designing complex systems, and solidifying core CS theory. I'm putting this out there for one reason only, accountability. This is how I train myself to articulate solutions clearly by speaking my thought process out loud. This isn't a guide or a course, it's just an unfiltered record of my progress. So this is day three, and I'll be doing the third question in the Leet Code 150. It's called two-sum, and it again is a Leet Code easy. So given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. The two numbers such they add up to the target. Got it. So you may assume that each input would have exactly one solution, but that's nice. And you may not use the same element twice. You can return the answer in any order. Okay, so 2 and 7 add up to 9, so 0 and 1. Yeah, and 1 and 2, so 2 and 4 add up to 6. Perfect. There don't seem to be any, so like elements can be any integer and the target can be any integer. Only one valid answer exists. Got it. So I think like the first solution is pretty straightforward. We can just have a nested loop, and since we can't use the same element twice, then like we can iterate on each element and match each subsequent element from that like current element and see if any of them, any of the pairs add up to the target number. So basically for int I equal to 0, I is less than nums dot size I, oops, I plus plus for int j equal to I plus 1. So this takes care of just checking subsequent numbers because yeah, like we don't want the same number twice, so we can't do I, and there's no point starting from 0 again because like when, for example, we are traversing uh, from 11, we don't need to check its compatibility from 2 again because we have already checked it while traversing it like for 2. So I is less than nums dot size and I, oh sorry, uh, j is less than nums dot size and j plus plus, and if nums of I plus nums of j is equals to target, then we return I comma j. And since we always exactly have one solution, uh, this should take care of it, but I'll still like to add an empty statement in case the input is wrong. So the return type of the function is still vector int and it should return something and not basically fall into a runtime error. Let me try run this. Yeah, accepted and perfect. That worked. And I see that there's a follow-up here. Can you confirm if the algorithm in less than no of n square time complexity, which I plan to. So what comes to mind is that I can use a hash map and basically uh, for each element I traverse in this array, I will save it in my hash map and for like every element I'll see that if its complement, if its counterpart from the target exists in the map. So in this case, like I'll save 2 in the map, then I'll move on to 7 and I'll say what's the complement of 7 with respect to 9? It's 2. So like 9 minus 7 is 2. And does 2 exist in the array? Yes, it does. So that's like that means the answer is present. I need information. Where does this element exist at? But yeah, like this information should be enough. Similarly, in this case, like we'll save 3 in the map first because its complement 3 does not exist. Then we'll move on to 2. We'll say its complement 4 does not exist. We'll save it in our hash map. And then for 4, we'll say its complement is 2 and it does exist in the hash map. So, you know, what's the position of that number? We'll save that in our map, and yeah, that should be enough. So what I plan to do is basically have an unordered map of int comma int and call it scene. So I'm not doing int comma bool because just knowing that the element exists is not enough here. What I also need to do is store the position at which that element was present. So, okay, let me get rid of all this. And so for each element, I'll first check that, does it complement exists. So I'll say that if uh, scene dot find uh, target minus numzi. Let's clean this up and call it int num2 find equal to target comma numzi. So basically complement of the current number in the array we're traversing, and we have to find that in our hash map. So num2 find, and if it is not like when we hit like this find operation basically traverses and like it the pointer points to the element uh, if it exists, and if it does not exist it will basically return the pointer scene.end. So if I do this, and this statement will be true when the element does not exist. So the find uh, this find function couldn't find this number in our map, and that's why the pointer is set to scene.end. So what we need to do is we need to say that does it exist, and if it does then we'll just return scene num2 find comma I. And again, if it does not exist, we need to populate this map for, you know, later traversals. So if it if it does not exist, we'll just say that uh, sorry, scene of nums of I equal to I, and this stores the index of the number with respect to the number as key so that we can look it up and find its index and return it. And this should be enough. So let me try it out and all test cases pass. Amazing. So yeah, this is like a faster solution. It is of time complexity O of n, I'm assuming, uh, because I already have one loop, and there's like O of n space complexity as well, because in the worst case we're storing like n minus 1 elements in the array. And the last solution basically, where was it? Oops. Uh, how do I get to that? Yeah, basically the last solution was a nested loop. Uh, so like in the worst case, we were traversing all the elements twice, and that's why the time complexity was O of n square, but the space complexity was O of 1. Like there was constant space. We were not using extra memory. So yeah, thank you.